Okay, so in this video we're going to look at turning word equations into balanced symbol equations, and I've written out a word equation, and the first thing you're going to ask yourself is, are your substances elements or are they compounds? So when you've got something by itself, like sodium, it's an element. Chlorine is by itself, it's an element. But here I've got sodium chloride, that's a compound. So compounds will contain two or more different types of elements. If you've got an element and you want to write the symbol for an element, it's really straightforward. You just go to the periodic table, find that element, and write down the symbol. So for sodium, when I find sodium on the periodic table, the symbol is Na. If I had lithium there, I'd write Li. If I had copper there, I would write Cu. So you just take it directly from the periodic table. However, there are a few exceptions to that, and they are called the diatomic elements. And your diatomic elements can be found in group 7. You've also got oxygen, nitrogen, and hydrogen. And by diatomic, I mean that if you have oxygen as an element or fluorine as an element, instead of the atoms existing individually, they will always pair up. And if we look at fluorine, we can see why they would do this. A fluorine atom has got 7 electrons in its outer shell, and it's unstable. But if a fluorine atom pairs up with another fluorine atom and forms an F2 molecule, then both atoms have a full outer shell. If you just have fluorine by itself as an element, rather than all of the atoms existing by themselves in an unstable state, they will all pair up and form F2. All of the halogens behave in the same way, as does oxygen, nitrogen, and hydrogen. If you've got the pure element nitrogen, instead of all of the nitrogen atoms existing by themselves, they will pair up and they will form N2. So if you've got any of these that I've circled as elements, you never write it as just the symbol, you have to include the 2. So going back to my previous example, I've got sodium and I've got chlorine. Because chlorine is diatomic, I have to write it as Cl and a little 2, okay? And that is only applicable when it is an element that I have to include that 2. If I go to the other side, I've got sodium chloride, and this is a compound. There are 2 types of compounds. There are ionic compounds and there are covalent compounds. In this case, you've got a metal and a non-metal, so you've got an ionic compound. And to work out the formula of an ionic compound, you need to use the charges on the ions. Sodium is in group 1, so has a charge of +1. Chlorine is in group 7, so will have a charge of -1. Your charges need to cancel. I've got a +1 charge and a -1 charge. Those charges cancel, so my formula is just NaCl. If your charges cancel straight away, you don't need to add any numbers to the formula. We're going to do another few examples of this below. Okay, so if I had sodium bromide, again that's ionic. Sodium is in group 1 and has a +1 charge. Bromine is in group 7 and has a -1 charge. +1 and -1 cancel, so I don't need any numbers. I just put the Na and the Br together. Notice that in my final answer I am not including any charges. The next one, lithium oxide. Lithium is in group 1 and has a +1 charge. Oxygen is in group 6 and has a -2 charge. +1, -2, those charges do not cancel. Because they don't cancel, I need to cross over the numbers. So what I'm going to do is I'm going to write the Li and the O underneath in the same order. The 2 that was next to the oxygen, I'm going to write down next to the lithium. The 1 that is next to the lithium, I cross over next to the oxygen. I don't actually need to include that 1, so my formula is just Li2O. The reason this is my formula is for my charges to balance. If I've got 2 minus charges, then I need 2 plus charges. Each lithium has a +1, so I need 2 lithiums to cancel out the 2 negative charge on the oxygen. The next one is magnesium oxide. Magnesium is in group 2 and has a +2 charge. Oxygen is in group 6 and has a -2 charge. These charges immediately cancel. I don't need to add any numbers to my formula. It's just going to be MgO. Next one, aluminium chloride. Aluminium is in group 3. It's got a +3 charge. Chlorine's in group 7 and has a -1 charge. +3 -1, these charges do not cancel. So I write down aluminium and I write down chlorine. The 3 that's next to the aluminium comes down next to the chlorine. The 1 that's next to chlorine can come down next to the aluminium. And again, that 1 is not needed. So I end up with AlCl3. Notice I'm not carrying down my pluses and minuses. I'm just carrying down my numbers. Your overall answer should not have any charges in it. So what I can see here is that if I've got 3 positive charges from aluminium, I need 3 negative charges. Each chlorine only has a 1 negative charge, so I need 3 chlorines to balance that out. Calcium nitride, I've got Ca plus 2 because it's in group 2, nitrogen minus. To get these charges to cancel, I've got plus 2, I've got minus 3. I'm going to write down my symbols underneath. I'm going to cross over the numbers. The 3 that's next to the nitrogen is going to come down here next to the calcium. The 2 that's next to the calcium comes down next to the nitrogen. Ca3N2. Copper 2 oxide. Copper is not in one of the main groups, it's in the transition elements. Because it's a metal, I know it's going to be positively charged, and in Roman numerals they have told me that that charge is going to be 2. Has to be positive because it's a metal, and because you've got 2 in Roman numerals, it's plus 2. Oxygen's in group 6, it has a minus 2 charge. Plus 2 minus 2 cancel out, so I get CuO as my formula. Last example here, copper 1 oxide. This time again, copper is a metal, so I know it's going to be plus, but instead of having a 2 in Roman numerals, I've got a 1, which means copper is plus 1. Oxygen's in group 6, so it's always minus 2. Plus 1 minus 2, they do not cancel out, so I need to cross my charges. The 2 that's next to the oxygen comes down here next to the copper. The 1 that was next to the copper, you can write down next to the oxygen. You get Cu2O. Iron 2 chloride, the symbol for iron is Fe. It's a metal, so it's going to be positively charged, and the 2 in Roman numerals tells me it's plus 2. Chlorine is in group 7, minus 1 charge. Those charges do not cancel, so I need to cross over the charges. The 1 comes down next to the iron, the 2 comes down next to the chlorine. I get FeCl2. Sorry, I should be writing that without a gap. FeCl2 as my final answer. And that is how you will write the formula of an ionic compound, which is what I did up. So the temptation when you're doing this equation is because you've got an Na here and a Cl2, the temptation is just for writing sodium chloride to just put the NaCl2 together. But we can see that if I work out the formula of sodium chloride using my charges, then the formula is not NaCl2, the formula is NaCl. For this reason, your equation is now not balanced, and you are going to have to go back and balance it. When you're balancing a chemical equation, you always use large numbers. When I was writing chemical formula, I used small numbers. I used small number for chlorine, and I used a small number in all of my ionic equations. You use small numbers for writing the chemical formula, but then when you're balancing, you're going to use large numbers. When you're using large numbers, you can only put it at the front of a substance. You can't insert a large number in between, and you can't put a large number at the end. So you have to put the large number at the front, and you can only use large numbers. If I look at my equation so far, I can see that I've got 1 sodium on the left and 1 sodium on the right, so they are currently balanced. But when I look at chlorine, I've got 2 chlorines on the left, and I've only got 1 chlorine on the right. I need 2 chlorines on the right hand side. I cannot just put a little 2 here because I can't use small 2's when I'm balancing. I can't just insert a 2 in between the Na and the Cl, which means that large 2 has to come at the front. Now I've got 2 chlorines on the left and 2 chlorines on the right, but by placing that large 2, I now also have 2 sodiums. If I've got 2 sodiums on the right, I need 2 sodiums on the left, so I'm going to put a large 2 in front of the Na on the left, and now I've got a balanced chemical equation. I'm going to do another few examples. I'm going to turn these word equations into symbol equations. So the first one, I've got sodium, bromine, and sodium bromide. Sodium is an element, bromine is an element, sodium bromide is a compound. The symbol for my element, I'm taking straight from the periodic table. It's going to be Na. The symbol for bromine as an element, it is diatomic because it's in group 7. So I'm writing the symbol from the periodic table, but I'm including that small 2. It's in group 7, it's diatomic. Then I need to write the formula for sodium bromide. Again, the temptation is just to put the Na and the Br2 together, but because it's a compound, an ionic compound, I need to work out the formula of sodium bromide using charges. Sodium is in group 1 and has a +1 charge. Bromine is in group 7 and has a -1 charge. Those charges cancel immediately. I don't need any small numbers when I'm writing the formula of sodium bromide. It's just NaBr. My equation is not balanced. I'm going to use big numbers to balance it. I've got 1 sodium on the left and 1 on the right, but I've got 2 bromines on the left and only 1 on the right. To balance, I'm going to need to put a large 2 in front of the sodium and the bromine, which means I'm going to need to go back and put a large 2 in front of the sodium. The next one, magnesium and bromine, forms magnesium bromide. Magnesium's an element, bromine's an element, magnesium bromide's a compound. The symbol for magnesium is Mg. It's not diatomic, so I'm just going to write it as Mg. Bromine, as we've seen above, is diatomic, so it's going to be Br2. For magnesium bromide, I need to work out this formula using the charges. Magnesium has a +2 charge, bromine has a -1 charge. Those charges don't immediately cancel, so I need to cross over the numbers. The 1 would come down next to the magnesium, the 2 would come down next to the bromine, and I get MgBr2 as my formula. MgBr2. In this case, I've got 1 magnesium on the left and right, I've got 2 bromines on the left and right, it is already balanced. Next one, I've got magnesium, an element, oxygen, an element, forming magnesium oxide, a compound. Magnesium is an element, I take the symbol straight from the periodic table, Mg. Oxygen is an element, so I'm writing O from the periodic table, but it is diatomic, so I have to write it as O2. When I'm writing the formula of magnesium oxide, it's an ionic compound, I need to use my charges. I can't just put the Mg and the O2 together. When I work out magnesium oxide, magnesium's +2, it's in group 2, oxygen's -2, it's in group 6, +2 and -2 cancel, so the formula is MgO. So my formula of magnesium oxide is MgO. Again, I can see that this is not balanced. I've got the right number of magnesiums on each side, but I've got 2 oxygens here and only 1 oxygen here. To balance, I need to use a large number. I have to put it at the front. Now I've got 2 oxygens on each side, but in doing so, I've now got 2 magnesiums on the right. I need 2 magnesiums on the left. Next one, lithium and oxygen going to lithium oxide. Lithium's an element, oxygen's an element, lithium oxide is a compound. Formula for lithium is Li, it's not diatomic, so I'm just writing Li. Oxygen, as we've seen above, is an element and it's diatomic, so it's O2. Forming lithium oxide, an ionic compound, I need to use my charges. Lithium's in group 1 with a +1 charge, oxygen's in group 6 with a -2 charge. Those charges do not cancel, so I need to cross Li2O. You can see here already that this is not balanced. I've got 2 oxygens on the left and 1 on the right, and my lithiums are also not balanced. You can balance either first. I'm going to start with oxygen. If I've got 2 oxygens on the left, then I need 2 oxygens on the right. I can't just use a small number. I have to use a large number for balancing, so I need to put that there. That gives me 2 oxygens on the left, 2 oxygens on the right. In terms of lithium, I now have 2 multiplied by 2. I've now got 4 lithiums on the right, which means I need 4 lithiums on the left, and I'm going to put a large 4 in front of lithium. It doesn't matter which way around you balance it, but in this case, balancing the oxygen first was helpful. If you started by the lithiums, then did the oxygens, then you would have had to go back and balance the lithiums again. That's fine if you have to do a little bit of trial and error when you're balancing, as long as your final answer, you've got everything balanced on each side. Next one, aluminium is an element, chlorine is an element, aluminium chloride is a compound. Aluminium is an element, it is not diatomic, so I just write down the symbol Al. Chlorine is an element, but it is diatomic, it's in group 7, so I'm writing it down as Cl2. And then I need to work out the formula for aluminium chloride. Aluminium is in group 3 with a +3 charge, chlorine's in group 7 with a -1 charge. To get those charges to cancel, my formula is going to have to be AlCl3. So I'm writing down AlCl3. To balance this, I've got 2 chlorines on one side and 3 on the other, so it's slightly harder to balance, okay? If you've got a 2 and a 3 and you need them to balance, you need the lowest number that 2 and 3 both divide into evenly. That is going to be 6. So I need to aim to have 6 chlorines on each side. To have 6 chlorines on this side, I'm going to need to multiply by 2. If I put a large 2 here, then I've got 2 times 3, I've got 6 chlorines. To have 6 chlorines on this side, I'm going to need to put a large 3 here. 3 times 2 is 6, 2 times 3 is 6. I've now got 6 chlorines on each side. By putting that large 2 there, it gave me 2 aluminiums. I need to put a large 2 here so that I have 2 aluminiums. Okay, so in order to balance this one, I asked myself, what's the lowest number they will both divide evenly into? The answer was 6, and I needed to make sure I had 6 chlorines on each side. I'm just going to do one more because this one's slightly different. I'm going to do number 8. I've got bromine by itself as an element. I've got lithium iodide, which is a compound, forming lithium bromide, which is a compound, and iodine, which is an element. Remember, if they're by themselves, they're elements. Together, it's a compound. When I'm writing the symbol of bromine, it's an element, but it is Br2. Forming lithium iodide, that's a compound. I need to work it out using charges. So I've got Li plus 1, I've got iodine minus 1. Those charges immediately cancel, and the formula is just going to be LiI. Lithium bromide, again, another compound. Lithium's in group 1, bromine's in group 7. Those charges immediately cancel, so I get LiBr. And then I'm forming iodine as an element, and iodine is in group 7, so the formula is going to be I2. So that is my equation. Is it balanced? No. I'm going to need to go back and balance it. I can see my lithiums are balanced on each side, but I've got 2 bromines on the left and only 1 bromine on the right. So I'm going to need to put a large 2 in front of the lithium bromide. With the iodine, I've got 2 on the left, I've only got 1 on the right, so I'm going to go back and balance my iodines. Now I've got 2 lithiums on the left and 2 lithiums on the right. Everything is fully balanced. Have a go with doing 6, 7, 9, 10, 11, 12. They're all the same. It's the same process. If it's an element, you write down the symbol straight from the periodic table. If it's a diatomic element, remember to include the 2. If it's an ionic compound, you need to use the charges and work out the formula of the ionic compound separately. You can't just slap the 2 things on the left together to form what's on the right. You have to work it out separately. You're using small numbers when you're writing your original formulas, but when you go back to balance, you're only using large numbers, and you have to put that large number at the front. You cannot insert it into the middle. Lots of these are exactly the same, but actually there are a few here at the end where I'm not forming an ionic compound, I'm forming a covalent compound. So I just want to talk for a second about writing the formulas of covalent compounds. This is easier than writing the formulas of ionic compounds because the name gives you a clue as to what the formula is going to be. So if you've got mon in your name, so carbon monoxide, it tells you you've only got 1. If it's di, it's 2, tri is 3, tetra, penta, hexa. So for example, carbon monoxide is carbon and 1 oxygen. Carbon dioxide, carbon and 2 oxygens. Carbon tetrachloride, carbon with 4 chlorines. Sulfur hexafluoride, sulfur with 6 fluorines. So with your covalent compounds, as long as you know what your numbers mean, sorry, I switched off. As long as you know what your numbers mean, you should be able to work out the formula of a covalent compound by just looking at the name. We will do one down here because I've got some of them here. I've got carbon and chlorine forming carbon tetrachloride. Okay, carbon by itself is an element, chlorine is an element, carbon tetrachloride, that is going to be a compound. Carbon is an element, so I'm just going to take C from the periodic table. It's not diatomic, so I'm just writing it as C. Chlorine is an element, but it is diatomic, so I'm going to write it as Cl2. Then carbon tetrachloride is going to be carbon with 4 chlorines attached, CCl4. Carbons are already balanced, but I've got 4 chlorines on this side. I've only got 2 on this side. I would need to insert a large 2 there, and now it is fully balanced. Okay, carbon and bromine, carbon tetrabromide would be exactly the same. I'll do the next 17. Nitrogen is an element, oxygen is an element, nitrogen dioxide is a compound. Nitrogen is an element, but it is diatomic, so it's N2. Oxygen is an element, but it is also diatomic, so that's O2. Forming nitrogen dioxide is going to be NO2. So di is 2, nitrogen dioxide is NO2. So So balancing this, you can see that the oxygens are already balanced, but I've got 2 nitrogens on the left and only 1 on the right. I need to put a large 2 here to give me 2 nitrogens on each side, but in doing so I've now created 4 oxygens on the right hand side. To have 4 oxygens on the left, I now need a large 2 in front of the O2. These ones here at the end, I've included hydrochloric acid. Okay, so that is something you are expected to know the formula for. It is HCl. So if I'll do this one here at the bottom. I've got magnesium. Magnesium is an element, hydrochloric acid is a compound, magnesium chloride is a compound, and hydrogen by itself is an element. Magnesium is not diatomic, so I just write Mg. Hydrochloric acid, you should know the formula of hydrochloric acid. It is HCl. Magnesium chloride is a compound. Okay, I need to work out, and it's an ionic compound, so I need to work out the formula of magnesium chloride. Mg has a 2+ charge, chlorine has a -1 charge. To get those charges to cancel, Cl2. And then hydrogen is an element, but it is diatomic, so I'm writing it as H2. It's really important that you know which ones are diatomic. Okay, so hydrogen is going to be H2. Then I need to go back and try and balance this. Okay, so you can see that I've got 2 hydrogens on the left, I've only got 1 hydrogen on the right, so I need to put a large 2 in front of the hydrogen. Okay, I've now got 2 chlorines on the left and 2 chlorines on the right, so that's all balanced. I've got 1 magnesium and I've got 1 magnesium. Okay, if you didn't start with hydrogen, if you started chlorine first, that's fine. Okay, sometimes you have to do a little bit of trial and error when you're balancing, but if you stick with it, you should be able to work out the final answer and you should be able to get it correct. Okay, remember, large numbers when you are balancing, you can't just insert it into the formula. And the other thing you really need to know is just which elements are diatomic. It's easy to remember because they're all in the same group, group 7, and you've just got hydrogen, nitrogen, and oxygen. If it's not circled, it's not diatomic, and you're just taking the symbol straight from the periodic table.